So in this video, we're going to talk about how to evaluate functions given an expression. So you already know how to solve problems like this, but just in case you need a review, please remember to watch the video that's posted in this lesson. So given f of x equals 3x plus 2, let's evaluate f of 1. So to evaluate this, remember what you do is you go to this function f and you plug in 1 everywhere you see an x. So that gives us 3 times 1 plus 2, which we now simplify. 3 times 1 is 3, and then we add 2, and then 3 plus 2 gives us 5. So we have f of 1 equals 5. Well, suppose I change this problem a little bit. What if I said now, given the same f of x, can you evaluate f of x plus 1? And so the process here is going to be very similar, but we're going to need to use a few extra steps. So remember back in Algebra 1, when you were simplifying algebraic expressions, you learned about the distributive property and combining like terms. So when we're evaluating functions given an expression, we're going to need to use these properties to help us simplify. So remember, the distributive property tells us what to do when we're multiplying an algebraic expression like x minus 3 by a constant like 4. Remember, the 4 is going to distribute to both terms that are within this expression. So we have 4 times x minus 4 times 3, which gives us 4x minus 12. Remember that we can also use combining like terms to combine and simplify algebraic expressions. So remember, to find like terms, you need to look for the same variable and the same exponent. So for example, 6x squared and 3x are not like terms, right? Because the exponents are different. But 6x squared and 3x squared are like terms. So what I did is identify the like terms using colors, right? So 6x squared, and then everything in orange, like 3x squared, is a like term. Next, we have 3x, okay? So every other term that has an x in it is going to be a like term. So that's why we have this minus 2x. Then we have 2y. Every other term that has a y is going to be a like term. So that's how we get 5y. Then I rearranged the terms in this expression to put the like terms together. So I got 6x squared plus 3x squared, 3x minus 2x, and then 2y plus 5y. 6x squared plus 3x, I'm going to combine these coefficients now, and that gives me 9x squared. 3x minus 2x, that gives me 1x, which I can just write as x. And then 2y plus 5y gives me 7y. So that's my final simplified expression. So now let's use all of this to go ahead and evaluate functions given an expression. So given f of x equals 3x plus 2, let's evaluate f of x plus 1. So I'm going to take this x plus 1 and I'm going to plug it into my original function everywhere I have x. So that's going to give me f of x plus 1 equals 3 times x plus 1. Okay, so you see all of x plus 1 gets plugged in for x. And then remember, I still have that plus 2. So I'm going to simplify this now, first using the distributive property. So I'm going to multiply both terms by 3. So I have 3x plus 3. And then I have this plus 2 hanging out here at the end. So now I just need to simplify by combining like terms. And the like terms I see are my 3 and 2, right? Because constants are like terms. So I have 3x plus 3 plus 2, which is 5. And that is now my simplified answer. So now, given f of x equals 2x plus 7, let's evaluate f of 3x minus 1. So I'm going to take this 3x minus 1, I'm going to plug it in for x in my original function. So f of 3x minus 1 equals 2 times 3x minus 1 plus 7. So I'm going to start off by distributing my 2. So that's going to give me 6x minus 2 plus 7. So now to simplify, I need to combine my like terms, and notice I have a minus 2 and a plus 7 that I can combine. So that's going to give me 6x plus 5 as my final answer. So now you can go ahead and pause the video and try doing this example on your own. So when you try this problem, you go ahead and take 2x plus 1 and plug it in for x into 3x plus 4. So that gives me 3 times 2x plus 1, and then I'm going to distribute my 3, which gives me 6x plus 3, and then I still have my plus 4. Since they're like terms now, my 3 and 4 will combine, which gives me a final answer of 6x plus 7. So now let's try this problem. Given f of x equals x squared plus 1, let's evaluate f of the square root of x plus 2. So f of the square root of x plus 2, and so all of that is going to get plugged in for x. Okay, so that means I have the square root of x plus 2 squared plus 1, right? Because I have x squared, so whatever I'm plugging in for x has to get squared before it's added to 1. Well, remember that squaring something and taking the square root are opposite operations, right? So these two operations are going to cancel each other out. So all I'm going to be left with then is my x plus 2. So I have x plus 2 plus 1. And so I can now combine these like terms, right? I have a 2 plus 1 that will combine. And so that's going to give me x plus 3, which is now my simplified expression. So now you can pause the video and try doing this example on your own. So we're evaluating f of the square root of x. So when we plug that in, we get the square root of x squared. Well, the square root and square are going to cancel each other out, so we're just left with x minus 4. So remember that you can evaluate a function at a given expression using a process similar to what you did when you were evaluating functions at a numerical value. Remember to use the distributive property and order of operations when you're simplifying algebraic expressions.